Hello one and all, I am Seshivitya, working as Associate Professor in the Department of Electronics and Communication Engineering at R.M.K College of Engineering and Technology. So today we are going to discuss implementation of Boolean function using multiplexer circuit. So this is, for example, implement the following Boolean function using 4 into 1 multiplexer circuit. So in this we are going to consider solution variables. So n is equal to the number of variables n is equal to 3. So a, b, c. Selection lines, the formula is n minus 1. So 3 minus 1 is 2. So you can just assume that selection lines as s1, s0. And then the type of the multiplexer that has to be used. Sometimes they may mention that the type of the multiplexer, sometimes they may not. In that case, we have to find the type of the multiplexer that has to be used. The formula is 2 power n minus 1 to 1 multiplexer, that is 2 power 3 minus 1 is 2, so therefore 2 power 2 to 1, which is nothing but 4 to 1 multiplexer. So number of input lines 2 power n minus 1, so 2 power 2, that is nothing but 4. So here to implement this Boolean function using this multiplexer, there are some instructions. So that is, we have to construct the implementation table. So in that, what you have to do is, so first we have to consider the given function that has to be circled. That is, first we have to mention all the minterms according to the number of variables given in the implementation table. And then we have to let's make the circle mark for the given minterms in the implementation table. Once it is circled, then you have to follow three conditions. So what are they is, in here that is, if both the minterms in the column are not circled, then you have to apply the 0 to the corresponding input. Suppose if both the minterms in the column are circled, then you can just apply 1 to the corresponding input. And sometimes if the bottom minterm is circled and top is not circled, then we can just apply C to the input. C is nothing but the last variable given in the function. Suppose if the top minterm is circled and at the same time bottom is not circled, in that case you can just apply C bar, that is the complement of the variable to the input. So this is a procedure to construct the implementation table. So here this is the implementation table. So they are just given three variables, so which will have 8 minterms, that is from 0 to 7. And we are going to use 4 into 1 multiplexer, so which will have 4 inputs, D0, D1, D2, D3. And here it is minterms from 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. So here it is, the last variable is nothing but C. So the first row we will be considering C bar, for the second row we will be considering it as C. So here we are going to follow that three conditions. Since in the first column, since both the minterms are not circled, so that we can just apply 0. And here both the minterms are circled, so we can just apply 1 to the corresponding input. In the third column, here this bottom minterm is circled, so that the corresponding variable is C, so we can write C. And in the last column, since the top minterm is circled, the corresponding variable is C bar, so you can just write it as C bar. Now we can just draw the circuit. That's multiplexer implementation. 4 into 1 multiplexer, 4 inputs D0, D1, D2, D3, 2 selection lines S1, S0. The remaining 2 variables are A and B. Here according to this, that is from this implementation table, we have to connect to the D0 to D3. So from the table, what is D0 is equal to? It is 0, so D0 is grounded. D1 is equal to 1, so D1 that has to be given to the 1. D2 is equal to C, so that can be connected to C here. And D3 is equal to C bar, that has to be connected to complement of the C. So likewise, you can just implement any multiplexer, that is any Boolean function using multiplexer circuit. So let us take the one more example. So f of x, y, z is equal to summation of 1, 2, 6, 7. So again it's in 3 variable and it has 4 minterms. You can just construct the implementation table. And again the formulas, we can just use that the previous problem that is values, and to find out the type of the multiplexer that has to be used for the implementation. So obviously since it has 3 variables and it has three variables, so the formula is that 2 power n minus 1 to 1 multiplexer. So obviously here also we are going to use 4 into 1 multiplexer. So implementation table D0, D1, D2, D3. And what's the last variable? It is nothing but Z. So for the first row, we are just assuming it as Z bar. And for the second row, we are just will be taking it as Z. Now 0, 1, 2, 3, 4, 5, 6, 7. 7, that is 0 to 7. Totally 8 minterms. Now the given function is 1, 2, 6, 7. So you can just make the circle mark for the 1, 2, 6, 7. Now you have to just look into the column wise. In the first column, since both the minterms are not circled, so that we can just apply 0. In the second column, the first, that is the topmost minterm is circled, so that the corresponding variable is z bar. We can write it as z bar. In the third column, since both the minterms are circled, so you can just apply 1 to the corresponding input. In the last one, the bottom, that is a second row minterm is circled, the corresponding variable is z. So we can write it as z. So likewise, you have to implement the table. That is the way we have to construct the implementation table. Now I can just implement using multiplexer. Since we are going to use 4 into 1 multiplexer, so D0, D1, D2, D3, two selection lines S1, S0, and the remaining minterms, that is the remaining variables are X and Y. Why? Because already I considered that the last variable Z for the implementation table. So what is D0? From this, D0 is equal to 0, so that has to be grounded. And then D1 is equal to Z bar, so D1 that has to be connected to Z bar. D2 is equal to 1, so that can be connected to 1 or to the plus 5 volt, both are same. And D3 is equal to Z. So likewise you can just connect it. And finally only one output. So likewise any that is a Boolean expression that can be implemented using multiple circuit. So these are all the other examples. P, Q, R S, 4 variables, and this is a given function, SOP function. So you can just construct the implementation table, 4 variables. So you should have minterms from 0 to 15. The last variable is S, so we can just consider S bar, S here. The same procedure that has to be followed. Finally, we can just implement using 8 into 1 multiplexer. Similarly here also. And if you just look into this third sum, f of a comma b comma c comma d is equal to, here it is given in the form of POS. Please remember that always any SOP function that can be implemented using multiplexer. Suppose if you are just given that POS function, then we have to consider, that is we have to convert that POS into SOP, that has to be considered for the implementation. For example, here it is POS function is given 0, 3, 5, 8, 9, 10, 12, 14 is nothing but POS. Obviously, what is the SOP? The remaining, that is the missing terms. What are they? 1, 2, 4, 6, 7, then 11, 13, 15. So that has to be considered in this implementation table. Please always remember the given function should be only in SOP form. Okay. Suppose if POS form is given, then we have to convert that into SOP and then we can just implement using multiplexer. So these are some that's a implementation using multiplexer. This is for your practice. Please do this one. And if you just look into the third one, again it's given in terms of Boolean expression, but what's the function is, it's a non-standard one. So you have to convert that non-standard into standard, and then we have to apply for the implementation. So okay, thank you. I hope you understood this implementation of multiplexer. Thank you.